welcome to another video. Today we are going to handle day 11 of Advent of Code. So let's jump right into it. Day 11, Dumbo Octopuses. You enter a large cavern full of rare bioluminescent Dumbo Octopuses. And they seem not to like the Christmas light on your submarine, so you turn them off for now. There are 100 octopuses arranged neatly in a 10 by 10 grid. Each octopus slowly gains energy over time and flashes brightly for a moment. And then the energy is full. Although your lights are off, maybe you should navigate through the cave without disturbing the octopuses. If you could predict when the flashes of light will happen, each octopus has an energy level. Your submarine can remotely measure the energy level of each octopus, your puzzle input, for example. And then we have some example input here, so I will take those over to my little script here. The energy level of each octopus is a value between 0 and 9. Here are the top left octopuses as an energy level of 5 and so on. Yeah. You can model the energy levels and flashes of lights in step. During a single step, the following occurs. First, the energy level of each octopus is increased by 1. Then any octopus with an energy level greater than 9 flashes. This increases the energy level of all adjacent octopuses by 1, including the octopuses that are diagonally adjacent. If this causes an octopus energy to be level greater than 9, it also flashes. This process continues as long as the octopuses keep having their energy level increased beyond 9. An octopus can only flash at once per step. Finally, any octopus that flashes during this step has its energy level set to 0 and it's used all its energy to flash. Adjacent flashes can cause an octopus to flash on a step even if it begins that step with very little energy, considering the middle octopus with 1 energy in this situation. Okay? So here we see that we have 1, 1, 1, 1, and 1 in the middle, and then we have a bunch of things that flashes here. So all these 8 around this flashes, which means that the middle will flash as well. What I don't really get is these in the at the end here, because we have 1 octopus here that flashes, which means that this should be a 1. But I guess that these 2 are also contributing to this value, which is a bit strange. But I guess that you can count the energy push multiple times, but you only have 1 flash, I guess. So then any octopus, okay, first increased by 1, then any octopus with the energy level of 9 increases the energy level of the adjacent octopuses by 1, including the octopuses that are diagonally. So, yeah, I guess so. Any octopus that is highlighted when it flashes during a given step. Here is how large an example process, and then they have a bunch of different steps here. After 100 steps, there are a total of 1,656 flashes. Given the starting energy levels of the Dumbo octopuses in your cave, simulate 100 steps. How many flashes are they? Yes, and I have already prepared by using day 9, and then we have new data here. And I have updated the file reader here to day 11. And we have a map with width and height, and we parse in the numbers. And then we have this sizes array, which is not interesting anymore. We need to go through the map, and we also need to have some kind of thing that could also visit neighboring things, so that's what this is all about. But I guess that we can start with having this map increase each value. So let's start there. So that's the step 1. Or part 1 of this step. And let's see here. Copy this text. So we have it readily available here. A lot of text. So finally, anything that has energy level more than 9 is set to 0. So I guess that here if map is larger than 9, then that map position should be 0. And we can take flashes equal to 0 and then increase flashes here as well. That's what I think we're doing in the last part here. And then we have a middle thing where we are using this check flash. Can do a void there. We will keep this visited array. That's still important, so we don't visit things multiple times. We don't change this. This should be the current state, for instance. So here, if we haven't visited this one, we should visit it as well. So that's next up. But here, if state is larger than, let's see, 9, then all the things around this should be increased by 1. So this should be increased by 1. No, this should not be increased by 1, but this should be. So there is 8 different steps. So first we can take the normal ones and increase those. So these should be increased. So that's all of them that aren't diagonal. And then we should have some diagonal ones, like that. So now we have done it with x plus 1, and then we do it with x minus 1 as well. So plus 1, minus 1. And it tells me that you need some parentheses made because this makes no sense. And of course they are right. So let's fix this. Let's do that. So now we have increased all the values around this specific point. And then we need to visit all of those values around. So I guess that this visited, no, it's not really needed because we will do this with all of them. I guess. So let's check flash on each of these values then. Map. And then do all of these. X plus 1. Y. X minus 1. Y plus 1. Minus 1. And then we will have plus 1. Minus 1, and these as well. Plus 1, minus 1. So let's try that example that we got with the smaller array with ones. And just try that once. So let's see here. For each step we increase by 1. Yeah, that makes sense. Yeah, because this will become a 2 first. And then after it has flashed, it's a 3. It's a 3. Yeah, so that's correct. So then we don't check the other ones. Is it just that we increase? So we don't flash again? I'm curious. So let's string data. Let's do an experiment here. 19119191191 There we go, and let's do 5 by 5, and let's just do that for easier. Yeah. So let's see here. We have 2 that increases, which is not correct. We need to do check flash. Map X, Y. Like that. So let's see here what happens with this little example. Oh, not day 10. We want to do day 11, of course. Let's do that. And we go here. And then we have a map of 3, 4, 5, 4, 3. And then the inner, yeah. So if we go to the start again here, oh, we can't really do that. So let's see if we can. Hello. It's just we have somewhere to anchor our endpoint here. Oh, we can just add flashes here. So let's do that and see how many flashes do we have. We have 9 flashes, and let's see here. Yeah, so the middle part is 0, 0, 0, 0, 0. So that seems great. Now we just need to do this multiple times. So it's going to be a lot of loops. So we want to iterate this 100 times. Oh my god, so many loops. Like that. And I guess that the flashes here need to be before this I counter. Or let's call it a J counter because we don't really care. It's just how many iterations we do. So we will remove this data here. And change this to 10. So how many flashes do we have then? Of course. -8. So we need to do a bunch of these checks if we are out of bounds, of course. And we had that in day 9, right? We had a bunch of these check things. So the flashes here should be removed. So yeah, we can just do some if statement. If x is less than width, we can do that. If x is larger than 0, we can do that. I guess these statements are going to be quite small, so let's just do it like that. And here we have if y is less than height, and if y is larger than 0. We did that. And here we have a bunch of them. So if and height that. So when we want to do plus, in this case y, then this could be 0. And if we want to do minus in y, then this needs to be more than 0. And here both of them needs to be more than 0. That. I wonder why our first example didn't encounter this problem. Check flash. Y should be less than height. What did we set height to? Height is 10. Let's see here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. So why is it 102 on this line? have -1 there? Yeah, because we want to add up to height. Yeah. So we need to have -1 on each of these. Having everything lined up is a hassle, but I think it makes for readability. So let's see. Yeah, so 1616, and I guess that was not the right number. What did we say down here? So 1656. So we have counted a bit too few. Flashes. So why is that? Do we have any computational issues here? Any octopus with energy level greater than 9 flashes. Okay, so that's not the issue. So let's do like this then. We need to do some modeling. We need to show each step here. Print map. I less than width times height. I plus plus. And system out print map I, and then we want here if I modulus width is equal to 0, then system out print line, and we also want to have some guiding lines around a little map here. So let's see here. Let's debug this. So we are here. We want to print our map. Yeah. Let's do that. So the first step should look something like this. Let's look. Looks very similar, right? Yes. So that's one step. And we have the next step. So that's step 1. Okay. need an extra step, perhaps? Is that our problem? Because this seems very similar. No, it doesn't. This is strange. This is so strange. Because the first map is totally correct. And then they say, from step 2, this number should flash. But that's 2 steps, right? Energy level of each octopus is increased by 1. Then any octopus level can model energy level by flashes in steps. During a single step, final octopus flashes during the step is an energy level set. Adjacent flashes to the octopus in a step if it begins that step. Very little energy, consider 1, yeah? So these I can understand, but this I can't, really. Because I get that these 2 flashes, yes, they become 0, but this one is an 8, so why would that flash? Doesn't really make any sense, right? There's nothing around it that can flash. Or is it 9, 8? So is it still that you need to visit every, but they can only flash 1? Yeah, it seems so. Seems so. Then we need to check flash. We need to have a visited kind of a map here. And we need to have all of this visited through down here, and Boolean, and then need to visit every other of these instead. So we can do it here, check flash, map, visited, do we need to keep track of if it has flashed already? That could be it. That could be it. There we go. So if we are here, then this has totally flashed already. So that's true. And here we need to check if state is, and it has not flashed yet. Then it can flash again. And then we need to have another array up here with flashed. How did this look? We got too few, but we still have... do we need to keep track on how many times it has flashed, perhaps? That could be it. So... has flashed. If this is false, true. While has flashed, we do this again. We just need to return a boolean here of has flashed. This is false, of course. Return has flashed. Flashed equals to true. No, false. And then we need to go back here and change all of these back again. Ah, Jesus. Oh, can we do this with history? Local history. I don't want to do this. So let's see here. We have this function down here with all of these changes. Let's do that. Copy these lines. Close that one. And paste these lines. Yeah, close enough. Yeah, no, just need to add -1 in a bunch of places here. Can actually return true. Yeah, I think that should be good. Yeah, we can return true here. And return false down here. That's pretty much what we want to do. And if we rerun this, what do we get? 1616. So we are back where we started. So let's see here. The second map. Why doesn't it do it again? So we can remove these has been visited because those are not interesting anymore. It's just if it has flashed that is interesting. So we don't flash multiple times. So let's see now how the map looks. We still haven't flashed these ones for some odd reason. Yes. Has flashed equal to false. If this is true, then has flashed is equal to true. And we don't need to do this increment, which means that we don't need to have this boolean. Just trying to simplify my code a bit here. Yes, now it looks correctly. And we get the right result. Finally. Jesus, that took a while. So the important part was to rerun things as long as something has flashed and then try again and see if we can get more things to flash. So let's see here if we get a good result. 1702 is the right result there. So let's put that in and see what we get. Yes, you get a gold star. I get a gold star. Everybody gets a gold star. So that was part 1. And I'm back for part 2. I had to take a little bit of a break there to gather my thoughts. Part 1 was really hard because I tried to do it recursively and that was not the case. We just needed to check multiple times, has any one of the other octopi been flashing here or not. So that was easy if you just don't miss anything. So let's see what part 2 entails. It seems that the individual flashes aren't bright enough to navigate. However, you might be better. Might be a better option. The flashes seems to be synchronizing. In the example above, the first time all octopi flashes simultaneously is step 195. If you can calculate the exact moments when the octopi will flash simultaneously, you should be able to navigate through the cavern. What is the first step during which all octopuses flashes? Yeah, so let's see here. Back to the code. We should be able to find it below 1000. Hopefully. And what we are looking for is when we have this flashes here, we can do that. And if the flashes are equal or larger than 100, then what flashes? What's wrong here? Not a statement. If flashes larger or equal to, then we take flashes and print those out, and we also print out J, how many, and then we will system exit 0. So if we did that, little change here, then we should get 194 is where all of them flashes, and so in this example above, the first time all octopi simultaneously is 195. Okay, and I got 194. So yeah, it's +1. Let's say that. So +1. Close enough. So if we do that with our real data, will we find it in the first 1,000? That's a question. Yes, we got it at 251. So let's try that. Yes, you get a gold star. I get a gold star. Everybody gets a gold star. Yes. So, what did we do today? Let's recap a bit. First off, we had some data here, and it was a grid of 10 by 10 numbers. So 100 numbers in total. And that was our octopuses in our map. We read in our map up here. Then we went through a bunch of steps, and each octopi's energy was increased by 1. Then we needed to figure out all the octopi that flashed, and they can only flash once per iteration or per step. So we will create an array here and say if something has flashed, and if so, we will also look for if any of them has flashed during this loop here. So while something has flashed, we will continue. Then we'll go through all of them and check if they flash. And in here, if this is something that could be flashed and it hasn't flashed before, so if it has a state 9 or above, then we'll say it has flashed, and all of the other ones around it will be increased. We will return true, or else we will return false. So we check if it has flashed, and then everything around it will be increased. And after that, we will count the number of flashes here. And it's just going through and see if any of them has a number above 9, and if so, we set it to 0, and we increase flashes. And then in the part B, we wanted to see when all of the 100 octopi flash it as one time. So we will check that and print it out here. Else, in part A, we just printed out how many flashes we had after 100 iterations. And we also built this little nifty function here in order to show our map what the current energy value of each octopi was. So that was day 11 of Advent of Code. I got sidetracked a bit, but I think I ended up in a good state. I hope that you found this interesting. I hope that you learned something today. If you liked this video, give it a like, share it with your friends and colleagues. Did you solve this in a totally different way? Leave a comment in the comment section down below. If you haven't subscribed yet, please do that. And I really hope to see you in the next video.